Have you ever tried to read emotions? Do you know anything about emotions recognition? Have you ever tried to read somebody's feeling? And maybe you know how a artificial intelligence can help us with it? So today's speaker is Sofio Katamadze from Tbilisi, and she will share with us the whole truth about emotions recognition using AI. Yeah, so uh, please listen to her presentation. It's really, really interesting. Also, if you have any questions during presentation, please leave them in chat and we will discuss it after the presentation. Sophia, stage is yours.
Thanks a lot, Alexander. Thanks everybody for joining our session. I'm Sofio, and today my topic will be about enhancing emotion recognition, EEG evaluation, and AI models. Shortly, I will talk about myself. I have more than 12 years experience in software development. I'm assistant professor in different universities, and I did PhD in computer science. That's mostly about me. And let's go to agenda. If it's first time you hear about a topic, please don't be afraid. I'll go step by step, and at the end of the session, you will have broader picture about emotions, electroencephalogram signals. Sometimes I will be just calling EEG, and how to recognize emotions by using our machine learning models and EEG signals, and what are the problems we have encountered while going deep in this area, and how we resolved all the stuff by literature review, a huge journey of it, and what is our output like unified framework, what we did for it. Okay, let's just start, okay, by emotions. What are emotions? Emotions play a crucial role in our daily life, on decision making. It affects a lot on our thoughts, on our feelings. They're actually complex physiological states, and it influences our mental health, our mental well-being, and it has quite big importance in different kind areas. And these areas can be medicine and healthcare. It can detect diseases like schizophrenia, maybe depression. An indication it has a big impact. It can give real-time feedback on students' engagement and comprehension. And why not? We can use it in legal and foreign use. Access emotional responses of the subject while doing some trials or investigations. And what if we can understand this emotion? Emotion, there are different kind of sources of getting emotion. Maybe it can be from videos, from biometrics or speech, but why not signals which are directly coming from the brain? It can be less ambiguous, right? So what are all these signals? We have different kind of physiological signals. So we have EG, we have EOG, EMG, and different ones as well. And EG, they capture direct neural activity. They're just coming from the brain. And they have precise insights into emotional states. And they're less ambiguous, as mentioned, than videos and speech because they are not masked, and we don't have here cultural differences. And it's quite cost effective. You can use just headset and you don't have to go to hospital, and it's non-invasive. You don't have to implant anything. You just have to use headset, and of course you can use it real time, just analyze it, and that's it. Quite simple and straightforward thing. Before going to our main achievement, let's start explaining how emotion recognition works with machine learning. There are different activities in our brain happening all over the time, and our goal is to get the emotion from this brain and from the brain these EEG signals, and how to do it. So input, we have this brain activation signals, and what is the output? Output is emotion. Or there are two definitions of emotion. One is person can be happy or sad, and another is we convert this emotion into two-dimensional scale called valence arousal. Valence is states from negative to positive, and arousal defines is the strength of the emotion. Here you can describe any kind of emotion by using two-dimensional scale. It means that we are converting regression task to binary classification, meaning that we have two classes at the end: high valence, low arousal, or low valence, high arousal. And the scale, the range of it for valence is from 1 to 9, and same is for arousal. I don't want to get things complicated, so let's just remember that input is brain signals and output is we get emotion, which is described as in two-dimensional scale. That's it. And how it goes now, well, how we can record it. It's just we wear this headset and we are wearing like on our scalp area to catch the neural activities which are directly fired and passed to these electrodes and then to our models. And what happens? Of course, we have to transform it to make ready before going into the ML model. And what we do, we might do some sampling, some filterings, or artifact removals because there can be some noise. We have to make data ready for input for AI model. And after it, we are classifying them using the AI models. The AI models learns with the emotion by using the EEG patterns and by studying the EEG pattern. And at the end, have the result. It means that a model sees unlabeled data by using all these identifying EEG patterns, and it says the what is the emotion. And this was like high level picture, and now let's continue. Is it all that good that okay we have this input, we have output, the emotion, so is it that straightforward? Not really, because we have encountered several problems while going deep in this field. It just signals they have a lot of noise and artifacts, and it's not so easy to identify the emotion from it. Okay, we have the data and how the data should be structured and what are the methods which should be processed, and because there are a lot of noisy signals, there are many artifacts, and what is the best method to process the data and how to split this data, and at the end how to evaluate it. Okay, I have results of my model, but is it comparable to your work? And it means that evaluation results of the model is quite important. And as we have researched in this area, there is a lack of evaluation methods. And we don't have baselines. There is no unified framework. You have to go to different kind of GitHub resources, research papers, and still you can't find the state of the art. What is the data, what is how to process it, how to compare it, etc. And what we did is that we did a huge journey of literature review. We started with different kind of the main sources, and we have researched, imagine, from 2020 for last 5 years, what papers have been written in main four sources from Google Scholar, Spring Link, PubMed, and Scopus. We have retrieved many papers and by using some keywords as emotion, recognition, EEG, or physiological signals. But at the end, we still got so many papers, and that's why we dropped duplicates and we did some filterings, maybe keywords, etc. But at the end, still we had a lot of papers, imagine more than 1,000 papers. And we did read all the abstract papers because and there did Rubens filtering. And so, as a result, and we also considered all the citations because it's quite important in scientific research. And we got 231 papers, and we did outline all the main aspects, all in these research papers, and considered what is going on in this field, what we have, what good and what are the pros and cons and what is lack in this field, and we considered everything. Even though we have a huge picture and we made a big Excel outlining all the stuff which were quite important aspects all over it, we could not compare the results of the papers. We could not evaluate that one research was better than another research. And that's why we decided those literature review to find the state of the art. And we are outlining here five main aspects which should be considered while we are doing the research in this area in EEG evaluations. So all these are data sets, data preprocessing, splitting, evaluation metrics, etc. And I will go one by one, and let's start maybe by data sets. There are different kind of say data sets which are available public for EEG and motion recognition. These are the Deep, Magnopsy, Dreamer, Amigos, and there are several of them. And these datasets are recording by using different headsets by different frequencies, and they're quite small. It means that while we are having them and processing them, we need to consider very even the very small effect which will affect the outcome. And in the literature review, what we have encountered is that many papers have used two datasets. Some papers have used one dataset. But is it enough? Because if I say that these datasets are quite small and different, it means that they are not comparable. I can't compare result of the deep to result of the SID, just for example. So our suggestion is to have all of the datasets used and processed by your models. Your results will impact the outcome and of course the development of this field. And yeah, unfortunately just one paper from Moses paper have used six datasets. That's why we put here as lack of standardization in EEG emotion recognition, one of them is dataset. Let's continue. How we can split data? We have to, of course, split data for training, for testing, for validating as well, and how to split it. There are different splitting types. We have subject independent, meaning that we have recordings from the different individuals. And here the most important method and famous one is LOSO, leave one subject out, meaning that we are testing on one subject and training with the rest of them. And there is also another splitting type called subject dependent. And here is also LOTO is same logic goes with LOSO, leave one trial out. One trial is used for testing and the rest of the trials are used for the training. And here, of course, there are different approaches, and we can't say that you should be using independent or dependent. But if you don't mention, it will affect the output of the results. You can't evaluate the results. And we have a lot of unknown splitting types in research papers that should be mentioned. And what we see here, we have plot the graph, and unknown splitting type is like 23 papers have not mentioned about it. And that's quite a big problem. And what is our suggestion is bit, yeah, it's cool. You use subject dependent, independent, but okay, let's mention it because it has quite big impact. That's why we put here data splitting as another consideration, and which should be, of course, done while you are doing this research work. Let's continue. We said that we have to, of course, process this data and how we should process the data. This data is quite noisy and has a lot of signals and frequencies. And what are the steps which we should do? I can say that maybe you have used a high sampling rate and you want to downsample it. Maybe you have to somehow window it 2 seconds, 1 second, and what we did is we analyzed what were mostly used in all these papers. And if you are new in this field, it quite be good and for you quite will be uh, comprehensive to use most popular ones. So you can start your work by popular methods because at the end your results will be more comparable and you can go and continue and make your contribution in this field quite easily. That's why we put here as a recommendation that, yeah, please use proper preprocessing methods, and we will cover it later as well. Let's continue. Ground truth splitting. What does it mean? We said that we have this two-dimensional scale, valence and arousal, and these scales are describing any emotion. And we are converting this scale into two classes, high and low. And how we are dividing that? What does it mean? We are dividing, but what is the threshold? Does it mean that if I have 4 as a threshold, it's good. Or if you have 5 as a threshold, it's good. But what we have encountered and discovered in research papers, it says that some papers have used as a threshold less than or equal to 5. Some excluded 5. Some less than equal to 4, etc. And there was no common approach for it. And is it good? No, because imagine that my result is 4, and I I have included this threshold less or equal to 4. In this case, it will fall in high class. But if I use this threshold, the 4 will less than equal to 5, it means that my result will fall in low class. It means that it is making results directly going from one class to another class. And it's bad that we don't have generalized approach. And that's why we put here ground truth splitting, the setting which should be considered, and we don't have here state of the art, and it would be good that, yeah, scientists will sit down and think what is best here to choose. Okay, let's continue. Okay, I have all these results, and I have these metrics, different kind of metrics like accuracy of one score, etc. But this is evaluation. It means that I already have data, I already process my data, and I have to work on my data. I mean, you have to, after it compares the results, what are the responses of the data? It should be comparable, and for it, you have to use corresponding evaluation matrix. What we have discovered in paper is that most of the papers have just used accuracy. Some of them have used different ones, but this one matrix is not sufficient. You can't rely on one matrix. And we have seen a lot of papers where one matrix would give a quite good result, but maybe F1 would not give. It means that for more reliability, you should use several of them and consider it in your research work. And yeah, that's why we put evaluation metrics as fifth aspect which should be considered while you are doing this research work. And how we could overcome after analyzing it came out idea that we can make some standardized approach and we can consider each of the outline in our work what is lack. So we decided to work on framework which will be and which is open source, and it has quite it's makes everything in a big pipeline and the whole process is quite unified. It helps us to compare the results. And you just have to run one line of the code and that's it. You don't have to even have some data science background or some engineering stuff. You can directly go with it and run it and you will see output. Maybe you are a scientist and you want to somehow contribute for and enhance this field. What are the components of our framework? It contains four main modules. First one is the data. Data, we have included all the main and public data for this field, and it has all the data structures considered and how they are split, etc. And even if you have some custom data recorded by your headset or whatever, you can have the custom data set. You just have to inherit and then go ahead. Next one is okay, you have data and you have to transform it. As we mentioned, there are famous transformation methods, preprocessing ones, which are good to start with. And here we have included implementation of all of them. Next one is models. What are the models which are used in this field mostly? And what are the common models? We have implemented them and you don't have to go through and find how they work, etc. And even if you have some custom model, you can inherit and then just fill up to function and here you go. And the next one is logger. So you don't have to um, f- worry about like how to compare your results. All of things you have in here, you just have to impart the logger and you have accuracy, precision, all the things which will impact the results and your output. Your work will be quite comparable and productive for the next time. What I want to do now is I want to just compare what was before and what we have now after doing this huge journey of research and then came up with this framework. Before, we had to understand the data structure, all the specifics, and we had to write what is it containing of this deep data and etc. And here what we do is we just have to import the data set. Next one is splitting type. As we mentioned, there are different splitting types, and you have to implement LOSO and how to deal with this with corresponding data. And in our case, we have to just choose the corresponding splitting type, and that's it. And also for transformation methods to uh, transform your data and to get ready for input for the model, you have to find which are preferred implement. In our case, you are just applying and that's it. And you have to find the implementation of the models, which models are good and how you can run them and use them. And it's quite important step and for investigation and for running, etc. And in our case, you have to import it. And as mentioned, this step is quite crucial because you have to write logging system and there were not included in many research papers proper metrics. We have applied all the required metrics and we promise that we'll be updating it all the time so that you can just apply and that's it. And running, yeah, it goes all the same and that's mostly as a comparison and as a result what we have all these data sets structured, we have applied these main splitting types, main preprocessing steps. Regarding the ground truth splitting, yeah, as mentioned, we should maybe come up with some kind of common approach to have it because we can't say that as a researcher that 4 is good, 5 is good, etc. And regarding evaluation metrics, yeah, we did find main evaluation steps, and we all included this in our work. And that was huge work. I wanted to make it very short, just not to confuse you with all this terminology and this work, just to make it comprehensive. And what are our main takeaways for you at this time is that in this field, which we have discovered last 5 years, including all the papers, we didn't have standardized approach for the main methods, and we have discovered everything, and we have also highlighted main aspects, and we made huge Excel file for it. And that's why, yeah, there was no unified framework. And what we did is that we came up with a framework which really allows efficient evaluation, and at the end we get comprehensive work and reliable. And yeah, it will be maybe somehow loud to say that we found the state of the art, but yeah, we approached at least. And of course, I should mention the contributors of this project. And this project is funded by European Union and Horizon Gain Twinning program. And we have our researchers, Tatia, we have our great team lead, Rafael, Natia, and myself. And we are working in this project with our supervisors and scientists, with Laura, Philip, and Benedict. And big thank to them for this contribution, and of course to this program to give us a chance for advancing and making somehow the contribution in this field. And okay, here you will ask that where is this framework or what you did? Maybe it's not really something worse, but we promise that we will be finalizing and publishing this framework, and it will be open source, and you all will have ability to just run it right away after we'll publish it. It will be quite soon. And also our research paper, which will have all outlines and quite many details, maybe which I did not just talk. It will be everything in this paper. It will be published soon. It's called Transactions Effective Computing. This is our future works and plan. And really, thank you for your attention. It's great to be part of this community, and thanks everybody for joining me. And now I'm ready for your questions, or maybe you have some kind of ideas and suggestions. Thanks a lot.
Yeah, thank you very much, Sofia. Yeah, we have questions, quite many. So let's talk. Yeah. So first question is, EEG is very noisy and reactive, and how to ensure the signal is taken from brain wave activity and really the motor activity.
Yeah, that's quite good question. Yeah, we have quite a lot of signals coming directly, and we have to, that's why use filtering it. We have to identify which are the relevant for our emotion recognition, and that's why we use different kind of filtering, like notch filtering, downsampling, etc. We are removing this noise, and also different physiological signals like EMG. EMGs, they are like muscular signals, and the EOG are ocular ones, like you have eye blinks, etc. And also it depends on the frequency, but mostly, yeah, we are filtering different physiological states to see and to just get EEG and identify emotions from them.
And yeah, we have a question, related question. What exactly is the emotion signal?
What exactly
Is
is emotion?
emotion
Okay.
signal?
Yeah, emotion signals. So we rely getting emotion signals directly from EEG signals. It means electroencephalogram signals. There are There can be multimodular approach, and of course we can identify these emotions from different sources, but we are getting and we are calling somehow these emotion signals which are directly uh, fired by neurons in the brain, and this is passing the electro signals to as a raw data, and we are getting it, and then we are transforming it and working. Yeah.
Uh, okay, I understand. And is this field really popular? And are there maybe some commercial projects around emotion recognition with AI?
Yeah, thanks. That's also our one investigation parts where we discover where it is used, why it is used, etc. Commonly in worldwide, it's not really used, and it's I mean in medicine abroad, like worldwide, and a main thing is that we it's not generalized, and that's why there are so many papers. But in commerce, like in medicine, you can say that we can rely on, I mean, in identifying emotions. Of course, EEG is always used to detect different kind of diseases, and it has been used worldwide quite many years. But regarding emotions, and this area is quite uh, developing, but it's not mm, commonly used right away. And our goal is to advance it and make this framework and data, because there is no so many data. Imagine we are working on different data, but they are quite small. You have to have many patients recording with corresponding diseases, and you have to then uh, train the models and identify. And now also we are trying to record, and we are continuing working on it. Yeah, and hopefully, yeah, it will have great outcomes later on.
You mentioned that data sets were quite small. So how small?
Yeah, for example,
Mm,
let's mention one data set. It had 40 patients recordings,
mm.
and they have watched maybe like 40 minutes videos, and they used different sessions, like how this is processed. They are stimuli is propagating by different videos, and these videos um, they um, make you somehow happy or sad, etc. And after it, you are evaluating it. And okay, there's 40 patients, so it means we have 40 subjects, several sessions, of course, done by them. And we can say that this data is huge, right? Because these patients are were specific disease diseases, and this data is not so accessible, I mean, from each hospital. And what we have is just public data where we worked on. And after we have huge amount of data, it will be quite easy, of course. And when you have quite comprehensive approaches for it, and yeah, other data are not also big. Some has 14 male and 9 females. Also, they have also used different culture people from different cultures, just to make it that say that they don't make difference regarding EEG signals. Yeah.
And yeah, you mentioned like all these data sets. There were all public data sets. There were like 10 or 5. Don't remember exactly. Yeah.
Yeah.
So, and what's the difference of them? Like, so is it a different measurement approach, or like a different devices or companies, or yeah? So
Yeah. Also, good highlight. Thank you. They are recording by using different headsets by different frequencies. Maybe one of them was recording like seed for thousands uh, hertz frequencies, and other maybe can be 256. and they have used different window sizes and sessions. Some of them used uh, for propagating the stimuli videos. Some of them has used different sources, and yeah, that's why the structure of them are different, and we can't compare them. Yeah, that's main reason and
And
highlight.
yeah, do you understand correctly that all these patients, subjects, uh, have been measured with these devices because they already have some emotional problems or some diseases, or they were also like healthy, like yeah, if I can say those, like healthy people.
Yeah, there were different kind of the patients over here.
Mhm,
There were some diseases, some healthy as well, to make the data more general.
mhm.
And this data sets, they made it worldwide, yeah, by different cultures and by different headsets. There are different headsets. I mean, for example, we have from Emotive one headset. There is also from Unicore another headset. It means that they have different number of channels channels what we have to put on the scalp, and they have also different frequencies. It means the data what we get, they are not same, and they have different structures inside.
And could you please share details about tech stack that you have used to process this data? I
uh,
mean, so
mhm.
what database or code have you used? Python or maybe Mongo, or so what was it?
Yeah, we mostly use the Python, and we are working by using mostly the PyTorch. And for evaluation metrics, we use here the tensor boards, and also for implementing all this EGNet and deception and these models, we use yeah, again, this Python and its approaches, which is uh, generally used in this area, and it will be quite easy to implement all the stuff because you just have to maybe fill up 4 lines, and you will be able to run your code and get the results right away.
And is it possible to read, for example, emotions of cats using this approach? What do you think? Like it's yeah. I really want to understand. Yeah, is my cat happy with me or not?
Yeah, that's quite tricky question. Yeah, by using this specific headset, uh, you have to put it on our like humans head, because we know like specific areas which they are being recording. For cats and for dogs, yeah, it is not use this kind of headset, but maybe we can understand it and work on such kind of projects.
And maybe
Okay,
it will be trickier to make them, yeah, like make
happy or sad,
yes,
yeah.
yeah, or maybe like only hungry or like full. Yeah, and could you share with us who is happier, women or men?
Here we don't really uh, uh, focus on the gender, because even recordings are different from the male and the female and from different cultures, and we really don't focus and separate them. And okay, that's a question, will remain as a question, I suppose. And let's, yeah.
Yeah, and what are your future plans? So you have mentioned how people can join, for example, yeah, and people can join your team. Is it open source project?
This is open source project, yes, and after we publish it, there can be many contributors who can, of course, submit a pull request and share their ideas with us. And that is our main goal to what we want. to develop this field, and that's why we made research of last 5 years. Why last 5 years? Because we had ongoing processes mostly in last 5 years, and all contributors were interested. They are all welcome, and so we want to mm, uh, we want everybody to see that it has quite big and huge impact on the if we know real human emotion. And yeah, that's why it was quite a huge work, and we are continuing this work. Our researchers and scientists are located in different countries, and they're quite this work they have contributed like in and dedicated their life mostly investigating all these signals and stuff, and that's why working with them is quite handy, and it's quite big opportunity for us. And we started this journey, we are continuing it, and anyone who wants to join, yeah, they're all welcome.
Yeah, we also have questions about this headset. Uh, can people of any age use this headset to 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 measure emotions?
These
Or
headsets, yeah, they have it depends on the type of the headset. They have some of them, the sizes even M, L, etc. For example, we had recently bought unicorn, and we just got M size. But if person, no, if we can adjust it, yeah, it depends. You should find, and it's quite easy. You just order it on any site, and you get it, and it has its own application. And here we go. And you main thing is we want to get the raw data from it, and after it we do our work. And of course we know all these things, which frequency it has, just to make correct filtering and preprocessing. And age depends on the size of, so if we can correctly put, because it has a big impact if we should correctly put on our scalp. And you should not really move, not to maybe cause another noise and stuff. And person should be able to assess the emotion. Of course, the child, if a child watch some kind of um, happy movies, they can't you see it, but you can't, they can't make self-assessment. So that will be for people who can at least read something or make some comments, not for very small people.
yeah, but for example, you measured emotions on like on your age
Yeah.
person, yeah, and for example, does it mean that after that you can understand what 1 year old boy feels? So using like same approach.
Yeah, that's the main goal actually, to identify the old kind of emotions. And EEG is quite used in hospitals, right? For you are getting different kind of diseases, and it doesn't matter you are 1 year old age or you are 40 years old, because you have all this EEG coming and the signals. Main thing is that we should put it in a, if it's possible to put it in a correct ways to, and the signals won't have so much noise, then it will happen.
And is it possible to read emotions during sleep? For
Yes.
example, maybe just to read dreams, something like that.
Well, that's a good thing to get to know what are my dreams. Actually, mm, current stage, yeah, what EG can do us, it's not magic. It's what is called emotions, and not dreams. Maybe in dream, if you feel better, we can get somehow. But in sleep state, usually the data, what we come, it's raw data is more in alpha state. It means that we get it in low frequency. So it means that we can filter it. That this data when person is sleeping, how sleep mode of the person, or maybe what kind of difficulties they have while sleeping it, and to study sleep manners. Yeah, but not dreams. We can't read dreams.
Okay. Yeah. Thank you very much for interesting topic. Yeah, and for interesting conversation. So I think with that we can end our meetup. Yeah. Thank you very much, Sofia, for coming and sharing with us your research. So thank you very much for asking great questions. Please don't forget to uh, set likes for this video and subscribe to our YouTube channel. So thank you very much.
Thanks a lot for making this meeting and everybody for joining us. Have a great day and Merry Christmas and Happy New Year. Thanks a
Yeah,
lot.
thank you. Bye.
Bye bye.